Hello. Good afternoon, everyone. Welcome back after the lunch break. So today I'm here to talk about DevOps for robotics. It's not that discussed topic in ROS or robotics, but it's one of the secret for scaling your deployment. That's something which I can guarantee. So just to give a brief intro of who I am Ragesh Ramachandran, and I work for Fraunhofer IPA, which is a research institute in Germany, in Stuttgart, and I'm a research associate there. And I work in software engineering and system integration team. And my research area is mainly on multi-robot systems and DevOps. So wherever there are more than one robots involved, I work there. So that's my interest point. So I don't know how many of you agree here, but I personally felt that software deployment is a nightmare. To people who I talked about, they also felt the same. So to understand why it is a nightmare, first let's understand what the workflow looks like. So understanding the workflow, it's more like there would be a bunch of developers sitting somewhere around the world, pushing the code to the repository, and there will be a build system configured in either the GitLab, GitHub, or private places. And it would be built, it will be tested, there will be some unit test or integration test, and it will be deployed. And if you look at it, in the deployment side, there is actually more than one person involved. And the reason is that, as some people used to say, that it takes a village to deploy a robot. It's true in most of the cases, because deployment is something which is not that straightforward, and there is no streamlined process to do that. So today's talk would be very technical, and I would like to make it very informative for you for understanding how to do a deployment and how to streamline that process. So let's first understand what deployment actually means. So there are like several ways to do deployment, but some of the most popular way people do the deployment is from install from source. So most people would have a Catkin workspace where they install everything on the source, and then they just run nodes on there. The second option is to install from package managers, which is like the normal sudo apt install or snap install, these kind of package managers. So that's also a way to actually deploy. And then comes this hot topic called containerization. So actually, some of the heavy lifting has been done by Gaurav from Black Coffee Robotics. He has talked about containerization. So it's actually good that you already have an intro of what it is. So containerization is like packaging your application and all its dependencies, configuration files into a single portable box. Let's put it that way. So to just give you a quick overview of what I'll be talking today will be like the challenges in robotics deployment and open source tools in action. And this would be like a story what I wanted to mention. And also optimizing the KPIs, which is associated with the robotic deployment. Let's talk about the challenges in robotic deployment first. So to understand this, first we need to understand how people usually update their robot. So deployment is about updating your system. So people who have Android phone knows how to update their software, how to update their apps. It happens through their app store. And people who have iOS, happens through the app store, it's done automatically. Nobody needs to know what is happening behind the hood. You just click update, it just updates to the new version. But in robotics, it's not straightforward. Somehow that doesn't look really nice. But so you have a version 1.1, a robot which has a blue light around it. Let's try to change the color of the robot, which means you need to update the robot. So the traditional process looks like something like this. It's boring, but it's something like this. First, you need to connect to the robot, and this is usually done through SSH. You typically SSH into a particular IP address, and you download it. And to do that, you either do git pull origin main, or it would be like sudo apt install, blah, blah, blah. Or, and then you have to deal with the dependency problem, which is like you install all the dependencies associated with each of the application that you install. If you don't have a proper package XML file, then all the dependency issues will be resolved manually, which is really, really tough. And then comes the part where you build it, which is Qualcomm build in terms of ROS2, but it can be Catkin make, Catkin build, whatever you want to use for the build tool. And then Once you are comfortable enough, you will run it using ROS to launch nodes. And then, ta-da, you have this green robot, like the robot with the green light around it. It's a new version. So isn't this process so ugly? I felt it's so ugly because it's too much of pain, because you can do it for one robot. But what if you have 5 robots? Doing it back and forth for 5 times, it's a linear process, like it's a sequential process. It takes time. So if one process takes like 5 minutes, it's like 5 times 25. If it is 10, it's like 5 times 10. If it is 100, like 5 times 100. So you are spending a lot of your time just doing the same manual work again and again. So to solve this is the secret I was trying to tell you. The secret is called DevOps. DevOps is actually a very simple term, but most of the people in the industry, especially the web development industry, has made it a very tough jargon that people find it really hard to grasp and understand. So let's try to demystify what DevOps is. So you see that this is like an infinite cycle, and the left part of the DevOps cycle is like dev part, which is the development part, and the other side, right side, is operational part. So in each of these cycle, there is a set of actions that is being done. So in the DevOps side, there is planning involved, there is code involved, and packaging, the application, build, test, release, monitor. Isn't it similar to what we did in the previous slide, just like SSHing into it and then doing all the process again? But it wasn't an infinite cycle because we were not having completion of that process. So to give a quick or a brief demystification term, DevOps is like a process where you control the way the software that you build on your laptop or a development machine is put to the production. And there is a philosophy around it, and it is done through a lot of collaboration and responsibility. I would say shared responsibility, because the DevOps team and operation teams are equally responsible for all the issues that happen throughout the process. So let's try to understand this with the example. It's a example that was, or not example, but a project that was carried out in my company in Fraunhofer under a project called Better Factory. So there was a factory floor, and it's a very big factory floor, and the factory floor has so many different areas like main office, inventory, R&D facility, manufacturing, and so many places. So the concept is that we need to monitor the area of the factory to understand the human traffic in it. So to understand where most of the people are walking around in the factory, this is for another follow-up project, but I wouldn't be talking in detail about what that project will be about. So the idea is to have some kind of 2D laser scanners that are placed around the factory floor to scan the entire area. So to use multiple scanners to scan the bigger area. So this is like a multi-robot problem to me, and I approached it. So to provide you the context, we started with a Raspberry Pi and a RP Lidar A2 to start scanning. A2 because it's a bit reliable than the A1 in terms of the resolution and about the working time it is able to work for. So we need to run this 24 hours by 7. And the idea is to make something like this, something which can be kept on the factory floor without disturbing the normal ecosystem on the factory. And the idea is to scale, which means there is a lot of work to be done repeatedly. So having got this problem, we know that there are certain set of steps that has to be done again and again. And these set of steps involve, since there is a Raspberry Pi involved in this process, the game starts with burning SD card with the right distro, for the right OS. And then setting up the configuration, then installing ROS and dependencies, configure the LiDAR, because each LiDAR has to know where it is located, because it's not performing any kind of self-localization or mapping, and then run the nodes. So this looks very much like a problem which can be automated, and it might look very simple, but it's one of the complicated thing to do for multiple devices, especially when you have like 10 plus devices and the possibility to scale after that. So, Okay. Uh, so let's go into a deeper dive into what I did. So I told about starting from burning the disk to running the nodes. So I tried to automate as much steps as possible. So I started from the perspective of a ROS application developer, where the application developer just writes the code for the application and then pushes the changes to GitHub. So that's where most of the people start from GitHub or GitLab or wherever the storage is done. And then, I don't know how many of you heard it, but there is something called GitHub Actions, which is one of the powerful tools one can use for automating a lot of iterative tasks. So with GitHub Actions, what happens is whenever you make a pull request or make a commit to the GitHub, you can trigger the GitHub Actions. You can tell the GitHub Actions that when you receive a commit, run something. Like you can actually tell to run anything, but you can, in this case, you have to tell to run the test, unit test, and some kind of integration test or whatever test that you wanted to run. And if things are good, if the tests are passed, it proceeds. If not, it just notifies the ROS developer. So the developer can actually modify the code and then make a fresh commit or a fresh pull request, and then things would start again. So it's a cycle. And if the things are done, according to my logic, I wanted the code to be packaged, bundled into a container. So here I'm using a Docker container. There are so many available versions for containerization, but based on your use case, please select the one. There is Podman as well. So based on my requirement, I want to use Docker. And I want to make a container using GitHub Actions. So it's same like what you did do on your own laptop, but I don't want to do this for every device that I want to deploy. So I did it online. And I push it to Docker Hub. This is not that difficult. You get the code for doing it online. And GitHub Actions itself has some open repositories which tells you how to do it. And by that, the developer is free from his task. Like as a developer, you don't need to worry much because your code is shipped. And now comes the work of deployment team. So deployment team has to write something called playbooks. This is based on a technology called as Ansible. I don't know how many of you have used it, but Ansible is one of the powerful IT automation tool which can be used for handling most of the repetitive tasks. And with Ansible, what we do is we write playbooks, which is like the set of actions that has to be done. And we have this SSH key for connecting to all the devices. And also we have an inventory file which contains all the IP address of all the devices that are there. And this is what my infrastructure would look like. So I have an on-premise server and also have a couple of edge devices, which are the laser scanners that I mentioned in the slide before. And through Ansible, I connect to all these devices on the private network, and I try to run a series of playbooks what would actually pull the containers from the Docker Hub. And in doing so, everything is updated in the same instant. And I'm not done there yet. I also have some kind of monitoring platform like Portainer, which is used to monitor the state of containers. And I also have a Prometheus plus Grafana combination to actually log some insights from these machines so that I can profile my code after this analytics. So yes, so we have seen the big picture and had a deeper dive into the problem. So as I have mentioned, there were so many tools involved in this process, starting from Raspberry Pi Imager, which is used to configure the network and burn the images into SD card. This might be a very simple tool, but is one of the most useful tool in this process. And then Docker, which is like containerization platform. And then I use GitHub Actions, which is a CI/CD platform to automate software deployment workflow. And then comes Ansible, which is a IT automation tool, which is used for pulling all the containers and putting it to the right place. And Portainer, which is used to monitor the state of the containers and its resources. and Grafana plus Prometheus to monitor the key metrics of CPU, like the CPU usage, memory consumption, network traffic, and so on, which is really important. So I was doing this, and I still do this same thing, but I used to think always, like, what if there is a tool, one tool which is helpful for all of these? Because it's really not that nice to learn all these different tools, because you will become a jack of all trades, but you will never be master of one tool. And the problem is you always stick to this set of tools and you'll never improvise, and you have to learn to live with the drawbacks of each of these tools. So what if there is a single tool which helps you to package code, do some simulation and testing on the cloud, just like GitHub Actions, but GitHub Action doesn't have so many extra features like testing on a simulator, for example, like a GPU-based simulator or something like that, checking all the edge cases. And what if there is a way to release and deploy with that a single tool and monitor as well? Because all these involve at least 5 tools. So that's where there is a DevOps platform for robots, and that's called Robot Air. So it's a dedicated platform for ROS-powered robots, and it helps you to containerize, test, deploy, and monitor. So it helps you to package your ROS app into a container, test the ROS application on the cloud, deploy the application over the air. Yes, over the air is something which I always dreamed of, and monitor your robot. So this is a very early stage product, and it's still undergoing the beta testing. So if somebody is interested to try it out, please check it out. It's in www.robotair.io, and you can scan the QR code if you want to see the website. So what did we achieve with DevOps? That's the first question that I need to address. With DevOps, actually we have an improved reliability because we automate the deployment, build, and all the processes involved, and because of that there is reduced human error, and which means the code that you deploy is more reliable because of repetitive process that's been automated. And there comes increased confidence. This is very simple, but which is something really important as well, because validating your software before it is being released for production, which means that there is a higher chance that it works without bugs. So it improves the confidence to the developer, to the entire company. And also it reduces the time to market, because if you have an automated pipeline to carry out all the process starting from build, test, and release, which means the moment you make some changes, it's being released. The only time it takes is to build the containers or do the test or perform some simulations. So you have a very dedicated pipeline which helps you to do that. So these are the 3 steps. There are several other key parameters which can be optimized, but these are the 3 things which I felt the DevOps can improve in your robotics workflow. So all the companies, startups who wanted to scale, start from building a proper DevOps pipeline, because you need that. Especially when you're working with robots, you need to have a proper DevOps pipeline starting from GitHub, like version controlling of your software, all the way to your releasing cycle. And yeah, that's the end of the presentation. I'll be happy to take some questions, but you can always reach me via LinkedIn. You can scan the QR code on the right. I'm always available on LinkedIn. If you have any questions, you can follow me there. I also write quite a lot about DevOps for robotics in LinkedIn. Also, I'm active on Medium, so follow me there if you want to read about ROS, robotics, and DevOps.
Thank you, Ragesh. So people, if you have any questions for Ragesh, you can take it offline. I'm sorry, we are stuck on time.
Yeah.